Alright, let's take a look at this problem. Integer to English words. It's a hard problem that asks us to convert a non-negative integer num to English word representations. So 123, we will have like empty space between, and if it is like 12, we have to say 12. And if it is like 1,000, 12,000, we have to say 1,000, and so on. So how do we approach this problem? So as you see, if we have a million, so if you have more than 6 digits, then we will have a million just before it. And since the range is 2 to the power of 31 minus 1, it will be around 4 billion. So 2 to the power of 32 is, I think it's 4 billion or something like that. So we have to create some dictionaries for this. Like for example, when we have 1,123, we will say 1 here, or like 21. 1,000, we say 1,000 in between, and then these digits we will say something different, 100, and then something like that. So we have to basically create a dictionary for different ways of saying different numbers. So the first one I want to do, this one digit, if there's only one digit, then we'll have like 1. We need capital. Okay, so 2, 2. Okay, this will take some time. 3, maybe like this. 4, 5, 6, 7, 8, 9. And then do it like this. Okay. Mm-hmm. Nine, 8, 7, 6, 5. And also 2 digits. This is gonna take some time, but yeah, two digits, or like second digits, or I mean it doesn't matter. When we have 2 digits, we will use this. If it is in between, if it is like between 10 and if it is between 10 and 19. So 10, so we'll have something like this. Right. 11, 12, 13, 14, 15, 16, 17. Okay. 10, 11. Oh. Eighteen. Okay. It took some time. So so we have to basically first decide if we have a billion or thousands, like or million. So we have to divide the number. So billion. So if you have a billion, how many billion we have? So for that, we have to divide number into 1, 2, 3, 1, 2, 3, 1 billion. And then we also want thousand, right? Oh, sorry, million. And that will be billion. No, num minus billion will give us, let's say that it's like 4.5 billion. Then 4.5 billion minus 4 billion will give us 500 million. Yeah. And because of that, we want to divide this to 3 million. Similarly, thousands. We want to have num minus, not num, but like I think, yeah. Yeah. Num minus billion minus million. Wait. 500 million, 500. For thousands, we divide it. We want to get rid of billion, million. We'll get like, let's say that 123,000. In that case, we want to divide this into thousands. We'll get the 1,000 there, and the remaining we will have the remaining like hundreds. I mean the rest remaining. Yeah, I'm gonna call it remaining. Will be basically, yeah, number minus billion minus, yeah, million minus thousands. So just to make sure that this is correct, let's maybe print it. Remaining. What do we have to return? String is fine. Okay, so it will be 0, 0, 0, 23. Now what do we have with this? That also works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This. It's not valid. Okay. Okay. I have a problem there. Actually, wait. 1, 2, 3, 4, 5. Oh, okay. We have to get the mode. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is, and then let's make it 0. So this is billion. We'll get 1 out of this. Oh, I shouldn't minus 1. I should minus billion. So it will be 1, 2, 3, 1, 2, 3. Yeah, it's times billion times 1, 2, 3 times 1, 2, 3. Now it will work. Okay. This should not be there. 7, 8, 9, 0. Okay, now it works. Right. Return string word string num. We'll have string num start be empty. So first thing is that, like, if we have a billion, if it is not 0, in that case we want to have a string num. So we have to add, like, calculate first 3 digits, or okay, we can only have 1 digit there because it can be at most 9. Actually, like 2 to the power of 32 is 4.3 billion. So 4.3 billion. So we will only use one of these. So I can basically, for billion, we can basically do this like 1 digit and then billion plus billion and so we'll have like 1 billion there. I should have space there. And then if we have a million, we'll have a string num. We add so now is the interesting part. We can have hundreds, like the third digit. What I mean by third digit is the 100, 200, the third digit from right side, when we're just focusing on the million digits. In that case, if we have, like, it will be like 100, 100, 200, and then it goes on like that, right? So for that, we just have to check if it is non-zero, the character. If we have a million, in that case, so this million will be 3 digit. We'll just take it. So maybe I should have some sort of, like, calculate, how to say it, stringify the million, and then we will have million there. By the way, one more thing, if we have billion or something before, like if we have if length of string num is greater than 0, then string num and space there. And then again we'll have the same thing, 1,000, million, 1,000 remaining. In the remaining one, we will not have something like this. In this one, we will have thousands. This will be thousands also. This will be remaining. Okay, so this looks duplicated, so I'm just gonna cut this. Should add merge string if necessary. So we'll just get the string num. So we'll have something like def merge string num. Okay, but wait, it will not work like that because we're not actually changing the original string. I mean, I'll have too many. I can only get rid of 2 tree lines, so I guess it's fine to have it like this. So if you have a billion, we'll just take it like this, put it there, and then we have a million. We will add an empty white space there, and then we add stringify it. So let's now focus on the stringify function. Basically, we want to, maybe just here. So let's define the stringify. We'll just get the num. If so, hundreds. So if hundreds, hundreds, 100. So we get the num. We divide by 100. We'll get, if it is 100, we'll get non-zero. Right? And then second digit, tens, like tens. In that case, we will have something like num minus 100 times 100. This will get how many tens we have. Maybe like we have 120. Then we will just get rid of 100, and then we will have 20 here in this case. And maybe also mod this. So that we'll have, divided by 10. And then remaining will be basically num minus 100, 100, and then tens. Okay. So we just have to. So if we have 100, then in that case, we basically will do similar operation as we did here. If we have 100, and then come here. Yeah. So we have that for that. Come here. If you have, okay, I won't need this. So if 100, then string, maybe like an if string current number string will be start empty. We will just current num string plus equal. If we have 100, of course, we will add that 100. So plus 100. Here we will have. So we will use like 1 digit there. Digits and 100. So let me make sure. Okay, we have 100 there. And then here now. Okay. I also should think about the 2-digit ones there. So if it is 1, I'll just, if the 100, like if the tens is 1 here, if tens is equal to 1, then we'll just add the next the 2-digit we will use a two-digit dictionary. So again, I'll just take this. Now we'll just use the 2 digits. We'll get the 10, not tens, but like we'll just get tens times 10, and then plus remaining, and then we will not add anything. We'll just stop here. Else, we will just continue, and then we'll add according to like 90. Oh, I also will need like 20, 30, 40, right? Okay, with like 2 digits. Maybe this should be like between teens. I'm just going to name them as teens. So here I'll use teens. Here I'll use 1 digit. Okay. Oh, actually, this will be teens. So 2. Okay. So we will use 2 digits. Will be like this, like 20. 20. Yeah, we'll just copy this. 30, 40, 50, 60, 70, 80, 90. Okay. 90, 90. 70, 60, 50, 40, 30, 40, 30, 90. Oh, right. So if it is not 1, if it is 1, we'll just do this. Otherwise, we'll just come here and then we'll basically just use the second. So let me just copy this. Okay. So like this. Okay. So use the 2 digits. So if you don't have 1 there, wait, actually, if it is 0, then we also skip this one too. Else, if tens equal to 0, in that case we just skip it. Maybe just make it like this, greater than 1. Yeah. So we'll just here use this second, like 2 digits. We'll get the tens. Actually, I made a mistake there. I don't need these. 7, 8, 9 tens. Okay. Okay, tens. And then if we have, maybe we have hundreds, something, and then because of that, we'll just add this. So we'll just put it here. String if following. Okay, adding a string there, like that. So if you have hundreds, so if you have hundreds, 100, here. Maybe even we can even put it here. Let's see. So if we have 100, we should put space, right there, and then here also we should put space. And then, okay, I guess we can merge some of these, or maybe have, yeah, something different there. But yeah, for now let's stick with this. So we have if 100, if we have 100, we put white space there, and then add this in the case where we have like 119 or something like that. If we have 100 and this is greater than 1, the tens is greater than 1, then we just take from here, and then what we do is that we basically have to, for the last digit, we have to There's not that one. You just check the remaining. Remaining. If we have remaining, if it is not 0, then we again do this. We have remaining. Actually, like this one. Or if you have tens, of course. If you don't have tens, then we don't have to put it here because we already have it here. Divide space. So if we have tens, we just put it like that, and then remaining. In that case, like let's say that it's 91, we'll just add like this 1 digit from there, and then pass the remaining, and that will be basically it. So we'll just, yeah, we'll just have it like that. I think this should be fine. I'm just gonna run it, but I'm pretty sure it won't work. Yeah, I forgot to return this, by the way. Return current string. Okay. Where is that slide? Or the okay. All right, 1,200,000,000. After 1,000,000,000. After 1,000,000,000. String num 1,200,000,000. Oh, okay. After 2, I don't have it. Where is it? 2. Okay, I don't have it here. Okay, it looks like it's working. Let's try other things. Oh, I have one. This should be that. 1,000,000,000. Where is 1,000,000? Okay, 1,000,000. Stringified a million. We should have a million right here, right? Print million. Let's only have the last one. We should get 1, right? Okay. We're getting 1, but this is not working. Why? Because no 100, no 10. Okay. And I got it now. So I should just, if remaining, I should just put it here. But there's one important thing. I think this again won't work. I'll get some extra things. Actually not. Let's try them again. 2000. 2012. Oh, okay. Yeah. If remaining and tens and tens greater than 1. Not 1. Not 1. Because if it is 1, then we don't want to do that. Okay. Now it looks like it's working. Maybe try different things here. 5, 6, 7, 8, 9, 10. Okay, it looks like it's working. Oh, I forgot about 0. Okay, I guess I can just do that here. If none, if not none, then you can just return 0. Okay, let's sum it again. Right. Yeah, where is that? Tens or 100. I should probably have like 34, 1, 0, 12, or something like that. Okay, try it again. Okay, it looks like it's working. Well, it was a little bit pain in the ass, but yeah. So there are lots of lines of code where it's just very, I don't know, looks dirty, but yeah, using this logic, adding strings when needed, like these ones, yeah. And here for empty spaces, and also structuring it for like with tree structure, like a block of I don't know what you call it, but like with 3 digits. Every time it changes the name of the, like if it becomes thousands or billion or million, it just changes when you have more than 3 digits added. Yeah, so based on that, we just structure it, and then since we are always doing the same thing for stringifying that 3 digits, we just modularize the code so that we will have one function that handles every case. And yeah, so this is basically the logic there. And also we had to get the million and billions like this, and this also looks a little bit dirty, but maybe there's a much better way of doing this. But yeah, it works, and I think that's it's pretty okay to have something like this, because yeah, we might have a much simpler way of solving this problem. I'm actually curious about the other um, solutions. Maybe they have very clean code. This is a recursive one. Let's check them actually. They're probably like 10 lines or something like that. Yeah, I think this is a bit extreme, but yeah, this looks much better. But it looks like we just need three. Also, we have the empty there, but I don't know how I handled that. Maybe with the if statements. But yeah, that was basically it. The integer to English words problem. This is the time complexity is just the number of digits. It's actually all of one because we are not using anything, and the maximum number of digits we can have is just 10. And also we don't need any additional space. These are also constant. So yeah, it's just all of one solution for like all of one problem actually. But yeah, I'm just gonna stop now.